Aslan Adnan, M.A., presents Top Science and Technology News so far in August 2026.
Strange quantum experiment suggests negative time is a real physical effect. Researchers confirm that photons can appear to spend less than zero time inside a material without violating Einstein's theory of relativity. Wednesday, the 5th of August 2026. Physicists have reported compelling new experimental evidence that an apparently paradoxical phenomenon known as negative time is a genuine feature of quantum mechanics rather than an artifact of measurement. The study examined how individual photons behaved while traveling through a dense cloud of atoms, where they appeared to emerge from the material sooner than classical physics would predict. The researchers measured the so-called dwell time, the interval during which a photon interacts with the atomic medium, and found that, under carefully controlled quantum conditions, this value could become negative. Although the result sounds as though particles are traveling backwards in time, this is not the case. No information, matter or energy is transmitted faster than light, and Einstein's theory of special relativity remains intact. Instead, the effect arises from quantum wave interference, where the probability waves describing photons interact in ways that alter the apparent transit time through the medium. By employing multiple independent measurement techniques, the team ruled out the possibility that the observation was simply a statistical illusion or an experimental artifact. The findings deepen scientists' understanding of quantum tunneling and light-matter interactions, with potential implications for quantum communications, precision sensing, and future photonic technologies. While the phenomenon remains deeply counterintuitive, it reinforces the remarkable ways in which quantum mechanics continues to challenge conventional notions of space and time. New 3D printing technique produces ultra-hard tungsten components. Breakthrough manufacturing process reduces waste while creating exceptionally durable industrial parts. Wednesday, the 5th of August 2026. Materials scientists have unveiled an innovative 3D printing process capable of producing some of the hardest tungsten carbide cobalt components ever manufactured using additive techniques. The advance promises to reduce production costs while improving the performance of critical industrial tools. Tungsten carbide cobalt is widely valued for its extreme hardness, wear resistance, and ability to withstand high temperatures. It is commonly used in mining equipment, aerospace components, precision cutting tools, and oil and gas drilling machinery. However, conventional manufacturing is both expensive and wasteful because the material is difficult to shape. The new technique enables engineers to print near-net-shape components with remarkable density and mechanical strength, substantially reducing the amount of costly raw material required. Researchers also demonstrated improved control over the microstructure of the printed parts, leading to enhanced hardness and durability compared with many previous additive manufacturing methods. Besides lowering manufacturing costs, the process could shorten production times and allow the creation of complex geometries that are impossible or prohibitively expensive using conventional machining. The development represents another important milestone in metal additive manufacturing, illustrating how advanced printing technologies are moving beyond rapid prototyping towards producing high-performance engineering components for demanding industrial applications. SpaceX Falcon 9 rocket stage expected to impact the Moon. Discarded upper stage from earlier lunar mission highlights the growing challenge of managing space debris. Wednesday, the 5th of August 2026. A spent second stage from a SpaceX Falcon 9 rocket is expected to collide with the Moon after drifting through cislunar space for many months following an earlier mission that deployed privately developed lunar landers. Mission analysts predicted the impact would occur during the early hours of Wednesday, although the exact location on the Moon's far side depends on small uncertainties in the object's trajectory. Because the collision is expected to occur on the far side, it is unlikely to be observed directly from Earth. The rocket stage has long since exhausted its fuel and poses no danger to people or satellites. Nevertheless, the event has reignited discussion about the increasing number of abandoned spacecraft and rocket stages accumulating in deep space. Although lunar impacts from human-made objects are uncommon, they provide scientists with opportunities to study impact dynamics and lunar geology by analyzing the resulting debris plume and crater using orbiting spacecraft. The incident also underscores the need for improved long-term planning in deep space missions. As lunar exploration accelerates, with governments and private companies launching more spacecraft towards the Moon, space agencies are increasingly considering strategies for responsible disposal of mission hardware to minimize unintended impacts and preserve scientifically valuable regions of the lunar surface. quantum computing achieves major milestone with built-in verification. Scientists demonstrate a quantum advantage while simultaneously proving the correctness of the computation. Wednesday, the 5th of August 2026. Researchers have achieved an important advance in quantum computing by demonstrating a quantum advantage experiment that includes an independent method of verifying the correctness of the result, a long-standing challenge in the field. Previous demonstrations of quantum advantage showed that quantum processors could solve certain specialized problems much faster than conventional supercomputers. However, verifying that the quantum computer had actually produced the correct answer often required calculations that were themselves prohibitively difficult for classical machines. The new approach overcomes this limitation by embedding a verification mechanism directly into the computation. As a result, researchers were able not only to demonstrate the superior performance of the quantum processor, but also to provide strong evidence that its output was correct. The achievement addresses one of the major criticisms surrounding quantum advantage claims, and represents a significant step towards trustworthy quantum computation. Reliable verification will be essential before quantum computers can be deployed in applications such as cryptography, pharmaceutical discovery, materials science, financial modeling, and complex optimization. Although large-scale fault-tolerant quantum computers remain years away, the study marks tangible progress in making quantum systems both powerful and dependable, bringing practical quantum computing a step closer to reality. FULL color night vision breakthrough could transform low-light imaging. Quantum dot technology enables infrared scenes to be viewed in natural-looking colors instead of traditional green. Wednesday, the 5th of August 2026. Scientists have developed a new generation of night vision technology capable of displaying infrared images in full color rather than the familiar green monochrome that has characterized night vision systems for decades. The breakthrough combines quantum dot materials with a specially engineered dual-layer organic light-emitting diode (OLED) display. Different infrared wavelengths are converted into distinct visible colors, producing images that more closely resemble natural daylight while preserving fine detail in extremely dark environments. Traditional night vision devices generally amplify available light or convert infrared radiation into green images because the human eye is particularly sensitive to green wavelengths. While effective, this approach provides limited color information, making it more difficult to distinguish between different materials or objects. The new system offers richer visual information, potentially improving situational awareness for military personnel, emergency responders, search and rescue teams, and autonomous vehicles operating in darkness or poor visibility. Researchers believe the technology could eventually find applications beyond defense, including medical imaging, industrial inspection, astronomy, and environmental monitoring. Further work will focus on reducing manufacturing costs, improving energy efficiency, and increasing image resolution before the technology becomes commercially available. The advance demonstrates the growing maturity of quantum dot photonics and highlights how nanotechnology continues to reshape next-generation imaging systems.
The author has placed this work in the public domain. It may be freely imported, exported, shared, distributed, edited, modified, or reformatted without explicit consent from the author. As a visually impaired person, the author asserts his rights under the Marrakesh Treaty to facilitate access to published works for persons who are blind, visually impaired, or otherwise print disabled. 2013, WIPO.INT